normal distribution stuff that we had before, like the weights of, the mass of worms, the height of tomato plants, all that stuff. It's never like perfect because it's in nature, but they all look something like that, where the average is in the middle, like average height, whatever it might be, and then there's fewer and fewer to either side, and then there's like some that are very short, very tall, something like that. In the real world, it's never going to be perfectly symmetrical. However, what we can do is, because they're close enough, we approximate it, and it simplifies things a lot. We say the standard normal distribution. Standard normal distribution is when the mean is 0 and the standard deviation is 1. And that makes things much simpler to work with, because there's also a formula for it as well. The way you convert between the two, z, which would be the z value for this, is the standard equivalent of x. It is the x value, take away the mean, divided by standard deviation. So we'll do that, and I think it'll be a bit more understandable. So let's try A. So turn the x of 53 into z.
So now we need to just make it the subject.
Z is already subject. What is x? What is mu? What is d?
X is 50.
Nope.
Oh, x is smaller than 53.
So let's just say 53.
Yeah. Minus, I don't know, is that 50 or 4? Or
50, yeah.
yeah. And then, will that just be 4 at the bottom?
Yep. And so what do you get there?
3/4.
So that's 3/4. And so the z value is 3/4. And so the probability that x is less than 53 is equal to this thing here, the phi. It's called the I can't draw this thing. The phi of 53, not 53, 3/4, 0.75. So I just want to see something. Did you put this thing into the graphical calculator? Did you get an answer for that one?
No, not yet. Sorry. So
it's all right.
If I now go to distribution, normal, and then was it NPD?
Always normal cumulative. Not yeah.
And then I should put it in here. So I'll put upper 53, lower 0, etc.
Yeah, to try that. Tell me what you get there.
I get 0.77.
Let's see. So was your one from?
Oh, I put lower 0.
No, probably 0.77.
Yeah.
Yeah, great. Let me just press exit. I'll just make that minus 999. Didn't even think about minus. Oh yes, of course. Yeah. So your one was the 0.77, and that's using like the real stuff. My one was also 0.77, and that's using the different one with a mean of 0, standard deviation of 1, and a phi of 0.75. Z is 0.75. And so it's the same thing. So it's a way to convert between a kind of real world normal distribution and what's called the standard normal distribution, which is this kind of simplified thing. And it's useful because it makes things easier. So how about part B? what is Z in part B?
Z will be now. Is it just going to be 54? No, 55. Sorry, minus 50 over 4, and so 5 over 4.
504. What is that? 1.25. And so that would be so the probability that x is greater than or equal to 55, which you could do in your calculator and all that, will be equal to the phi of 1.25. Yeah. Okay, so far so good. That's what it looks like. 0.75. And oh, hang on. Why are they doing this to me? It's 1 minus that one. I'm not going to worry about that because, well, we'll see. We'll see how we do. Let me just see something. All right. Yeah, let's try this.
Okay, so
hang on, this strikes me as something else. It strikes me as kind of inverse normal. Maybe that's in the wrong place, is it? No, it isn't. This is what they want us to do. Ah, Bookie, why did you make me do this stuff then? If I didn't have to. Hang on. This is what they should have done next. Probability. Yep. Okay. What is this?
I think, do I now need to do, so if I use the formula Z is equals to X minus mu over D, do I then do 0.2, or is it not 0? I know that mu is mu and D is 3.
So we have, that's mu, that's 3. The problem is we don't have Z and X.
Is X 20?
Probability X is greater than 20. So that would be 20. Yes. What about Z? How do we go about that?
Z isn't 0.2, is it?
Nope. For this, we can. So we're asked. Well, one way you could do it, a terrible way, but one way you could do it is, so X is greater than 20. So lower is 20, upper 999. Standard deviation is 3. And when it comes to mu, we could just try lots of different stuff. So we could try 7, and that gives us something very small number. We could try 15. That gives us 0.04. We know that it should be 0.2. And you could try different means until you got something close to 0.2. So that's a pretty terrible way to do it. A better way to do it is inverse normal. Distribution, normal, inverse normal. So how would you do it using inverse normal?
So if we put in for the D, we sub in the numbers for?
Yeah. So yep. What is hang on, we need the mean is greater than is equal to 0.2. So that is to give us X Hold on. Find mu. Okay. Mm-hmm. 0.87. Uh-huh. Calculate their mu at 0. Okay. Aha. Yes. So we need the Z value. Here's how we do it. What is the tail if it's greater than?
20.
So that's going to be, 0.20 or 0.2.
Yeah.
For the standard normal, what would the standard normal stuff be?
Is that like upper and lower?
No. For the standard normal deviation, what's the mean? What's the standard deviation?
3.
No, standard normal. Always the same mean, always the same standard deviation.
So the standard normal variable is written as Z is.
Hold on.
Okay.
Real world, you're always gonna have a different average. You're always gonna have a different standard deviation. But they're always gonna be the same kind of shape, and they're always gonna have the same kind of proportion. And because of that, smart man standardized it down to its simplest, which is a mean of 0, a standard deviation of 1. So you have, in the real world, many different distributions. One that comes up a lot so often is that it's called the normal distribution. And you can standardize that to be called the standard normal distribution, where it has a mean of 0 and standard deviation of 1.
Okay.
So calculator, what is deviation? What is mean?
So deviation is 1, mean is 0.
Yep. And what way will the tail go for greater than?
Sorry, could you repeat that, please?
What way will the tail go if it's for greater than?
Right.
Yeah. And so let us see. And so that is it. So the probability that x is greater than 20 is 0.2, or in the standard normal, the probability, the x, or this is the z value, 84162. 84162. So I didn't have any kind of more practice questions. Let's just see. But this previous one here, remember how you did it in terms of x? You put into your calculator 53, 54, and you got 0.77. And I put into the calculator 0.75 and 1 and 0, standard deviation of 1, mean is 0, and I got the same number, 0.77. So if you know the mean, the actual mean, actual standard, actual deviation, then you can get the probability. Or you can use the standard normal, because they are they're the same idea. You could have two distributions. The actual mean for this one was 50, and it's got a standard deviation of 4. In the standard normal, that corresponds to 0 with a deviation of 1. Let's say, so 0.77 is like roughly 3/4. And so that's kind of roughly 3/4 there. And in this other one, it would be exactly the same amount. It'd be exactly the same 3/4. And so we can use that to find unknowns, like unknown mean, unknown standard deviation, using this formula, z equals x minus mu over d. Let's see. So there's the probability that x is greater than 20. Let me just see some. Yeah, probability that x is greater than 20 is 0.2. So we don't know the mean. We know the deviation is 3. And we know that it's got an area of 0.2. So it's like 20% of the total. This x here is 20. But in terms of z, it is 0.84162. And so we can sub z and x and deviation into our formula and solve for mu. And so what would be mu? How do you get that?
By just solving. So 3 times 0.84 divided by 20.
Okay.
And then swap the symbols around as well. So
yeah, sorry.
So I got 17.5.
So mu is 17.5 and 17.5. Yes. Actually, hang on. We're gonna. All right. Let me see. Yeah, let's try this one.
Are we using the same formula?
Yep.
So z is equals to x minus mu over d. X is 46. Is it like 46 minus 50 over d squared?
Just d.
Oh, sorry, yeah, d, yeah. And now 0.22, 0.21. So I forgot what we did again to get to the z bit.
Inverse normal. So you have to find the inverse normal will get you the z that gives you an area of 0.2119.
So am I going to put it as left for tail because x is smaller than 46?
Well done.
And area 0.2119.
Mm-hmm.
And then mu is just mu. Oh no, sorry, d is d and mu is 50.
In the standard normal, deviation is always 1, mean is always 0, and that allows us to work in reverse to find the z.
And so now I got inverse normal as minus 0.799846.
Okay, and so that is z minus 0, and so solve, and you can use calculator if you like.
Yeah.
6.
Five.
What is it?
5.
Exactly 5?
Basically, there's like 3 zeros after the decimal point, so yeah.
I'm gonna write 5.00 because that's got 3 sig fig. Okay, they wrote 5 as well. Okay. Yeah. So let's see. Big picture. Big picture is we know the mean and the x. We want the standard deviation that will give us a probability or an area of 0.2119. Problem is we don't know the deviation, but we do have a formula that connects x, mu, and d. Problem is it also has z, and so to get the z, we have to say what z, which is like the standard form of x, will give us an area of 0.2119, and then we work in reverse from there. What was I going to say? So for this one, we don't have the deviation, but for the standard one, standard normal, we always have the mean and standard deviation. They're always 1 and 0, and so that allows us to do it. Any or many questions?
No.
This is a great question. Let's try this one.
Okay. So, z equals, I'm not sure if it's going to help, but z is equals to x minus mu over d.
That's going to help a lot.
And I think I need to do that twice, like 30,
Correct.
x is 35 in the first one,
Mm-hmm.
d in the second one.
15 in the second one, yeah.
Shall I do them one at a time?
Yeah, it's usually how you solve equations.
Yeah, sorry. And now we need to just put minus mu over d.
Mm-hmm.
And so should I just... So I know we just said that these are 1 and 0, but I'm assuming here that the answers may be 1 and 0.
1 and 0 are always that for the standard normal. We want for this specific normal, whatever this is, worms, tomato plants. We know that the probability that x is greater than 35 is 0.025. And so what z would give you, what would the probability of z would be greater than, sorry, it was 0.025. So what z value would give you 0.025? That's what you have to find.
Okay. Should I just sub in 1 and 0 here, or
Yeah. Into where?
into the equation?
No,
I know.
because that's for the standard normal. This is a specific normal.
Which is specific normal, sorry.
This is like this specific normal. So this might be, the height of tomato plants or something. But the standard normal is just a simplified model of reality, where the average is 0, the standard deviation is 1. So let's hang on. Stats. Let me go back to this one. So normal. If I did normal cumulative, so for this one, x is greater than 35. So the lower is 35, upper is 999. And the problem is I need a standard deviation and a mean that will it has to give me an answer of 0.025. Yeah? So
Yeah.
standard deviation could be, I don't know, could be anything. Could be 4, 5. Mean could be 7, but when I press enter, I need to get a probability of 0.025. The problem is I've got two unknowns. I've got a standard deviation unknown, I've got a mean unknown. However, the probability of it being 0.025 will be the same for the specific normal as it is for the standard normal. And so in the standard normal, the mean is always 0, the standard deviation is always 1, and I need a z that gives me an area of 0.025.
Okay.
And this is greater than, so it'll be right.
So
So put that into calculator.
yeah.
So that's inverse normal.
Sorry. So when so is it when x is greater than the number, then it's right?
Yep. Less than
Okay.
would be left.
0, 2, 5, 1, 0. So I got. Should I say what I got?
Yep.
I got inverse normal of 1.95.
Great. And so before we, so that's z, but let's just make sense of that. 1.9599. I'm going to write 6. Let's just make sense of that. Let me go back out. So instead of inverse normal, I will just do normal cumulative. For standard normal, standard deviation is 1, mean is 0. This is greater than, so the upper is 999, but the lower in this case is what we just got, 1.95996. And if this is correct, then the probability should be 0.025. And it's very close because I had to round it. So inverse normal just gets us the x that would give us that probability. In this case, it's not called x, it's now called z, because it's not the normal, it's the standard normal, where the deviation is always 1 and the mean is always 0. Okay, we have one equation. What's next?
Can I now use that equation to sub in as for the z of the next equation?
Yep.
And so do 1.9599.
No.
Oh no.
Different z.
Yeah.
We now need what z gives us a probability of 0.1469.
And so now we're doing tail left. Area 0.1469.
Mm-hmm.
And my answer here is minus 1.0498219.
Correct. What's next?
Do I now? Okay, I think I need. Do I now need to make a simultaneous equation
Yeah.
and then? Yeah. So if I do, for example, if I for the first equation solve for d, would it just be like d is equals to 35 minus mu over 1.9599?
Yeah.
And so I then sub that into the next equation.
Yeah.
As d, so I end up with minus 1.0. I'll put it to my calculator. So I remember.
Yeah.
So
you could make them both equal to d and then make them both equal to each other. That might be easier.
Yeah. So if I do, yeah, okay, I'll do that, and then that'll be option calc. So then, 35 minus mu over 1.9599.
Mm-hmm. So we make the 35 minus mu Oh, maybe I take it back.
And then I can just do like 15 minus mu over, equals to 15 minus mu over minus 1.0498.
You sound like you know what you're doing. I'll let you go for it.
Cheers, thanks. Okay.
I have another idea, but go on.
And so for mu, I got my first answer is 22.0.
Okay.
And now, if I just sub that answer in and do sorry, if I do. I got that D is equals to minus 14.3.
I got it. It's equal to 6.65. Maybe I put something in wrong. And that the other one was 22.0. So 22.0. How did you get your standard deviation one?
I basically, instead of putting 22.0, I just put the answer they gave me initially, which was like 21.97611, etc.
And where did you sub that into?
I did 15 minus answer over x equals to minus 1.0498.
That should have worked. Maybe it just typed it in wrong. That should work. It's a good method. It might just be because it's minus in there somewhere. I'll show you this way that I did it, and I think it might be easier.
Yeah.
You know how you brought the delta to the other side?
Yeah.
And then and it's just simultaneous equations then.
Yeah.
And I think that'll be easier because you get both answers in one go. Because the subbing in part, this is 15 minus mu, and you have. Well, you see, I should have. Yeah, see, it's just you've got a minus here, you've got a minus there, you've got x in the denominator. Yeah, we'll do it using simultaneous equations. Let's see about this. So this is the correct answer. Okay, but I'll tell you what's going on here. What's going on here is we did it backwards, but we never actually did it forwards except for the example. And that's why this is so strange. The reason why we didn't do it forwards is because we don't need to. Because when this used to be taught, back when I started teaching it, it was like brutally difficult. This new graphical calculator, it's like it's galling how easy it is. Like you literally just put in the numbers. It's like it would be like if Suvat, if they just put in 3 and we give you the other 2, you know. Except these calculations used to be like very difficult. Looking up, let me just show you. Do I have one? They have these, they have these tables that you have to look up and stuff. And that's just a little part of the table. So we did it forwards. We never actually did it backwards. And so what I want to find is questions where we do it forwards, because that would be helpful. Because this is all like they're assuming the forward one that we'll do it their way, but we won't. All right, let's just do some happy stuff. Let's see, what is 1a? How'd you do that?
So would you put into our calculator?
Yeah, go on. What do you put into your calculator?
I will put in sorry. So if I go to statistics into the calculator and then put in left
Mm-hmm.
tail.
No, that is inverse normal. That would be if you know the area and you're trying to find the Z that gives you that area.
So we're just going to do normal cumulative distribution.
Yeah, exactly.
Which would be lower 2.12, upper 999.
That would be for greater than 2.12.
So is it 2.12 upper and then lower 0?
Yeah, use minus 999, something like that.
Yeah, okay. And so now I put, 1 is mu, no, 1 is d, mu is 0, and then just equals.
Mm-hmm.
And I got 0.98.
Lovely. Grant, how would you do very last one, H?
Do I have to do it into like 2 separate goes?
You could, if let's look at G. Let's do G instead. You could do it in 2 separate goes, and if you didn't have a graphical calculator, the answer would be yes, but you do.
So I feel like so I'm not using inverse distribution here.
No, inverse was doing it in reverse. This is just doing it forwards.
Do I have to change variable to list or something? Or
No.
oh, I know. I need to put lower minus 2.16, upper minus 0.85.
Yes. What do you get?
0.18.
That's it, and that's what it looks like. 0.18, and the and so the ones that we were doing backwards is we are told that this here, let's say this value here is well, we're told the area is 0.18, and you have to find the Z that gives you that. That's what the inverse normal does. Well, anyway, let me take the. I just wanted to do that more challenging one. So we've been doing this forwards. I want to try to make sense of this. 1 second. No, not yet. No, let's just do happy stuff. Okay, question 2. What is 2a?
So will 2a just be? Oh, now I'm doing inverse normal, aren't I?
Yep, exactly.
And so if I go back to inverse normal, that will be so variable right. Oh no, left. Sorry, left.
Mm-hmm.
Area 0.9082.
Yeah.
And mu is 1. No, d is 1, mu is 0.
Yeah.
And I got 1.3. Oh no, well, 1.33.
Okay, so yeah, in that case, that's that A. Probability that Z is less than something gives you this, like 90.8% of the thing, and so that value is 0.133. That's fine. Sure. Yes. Let me see this. The random variable x reach the following x. Yeah. Yeah. So I see what they were thinking, but it's just much easier. Okay, so let me just look in the other one. These seem very similar in terms of that. Yeah. Okay, so if I now go back to the ones that we were doing, I think it will help to have a diagram. So I need to do the diagram myself. I went over this one. So let's say this was the very first one we did. Hang on a second. Come on laptop. Let me put that there. So they have a diagram for me already. I'll use their diagram. We're told that the probability that x is greater than 20 is 0.2. Well, we also know that the probability that z is greater than something will be 0.2. And so we first look up what z will give us a probability greater than 0.2. We do that using our inverse. And then once we have the z, we can use that to solve for whatever we need in the equation z equals x minus mu over d. So that's the way we should have done it. We should have done it forwards first, backwards second. I skipped over loads of questions. I'll show you why. How do we do part A?
So we need to get up some sort of percentage points table.
Sure. So you'd go into your formula booklet and you'd look up this thing. That's long, man.
It is long.
Inverse normal. Just what z gives you that. Just calculate our whole thing.
Yeah, so area 0.025. Table right. And just enter.
Yep.
1.95. No, 1.96. Sorry.
So that's 1.96. 0.025. That's 2.5%. I'll go back to our little table. 0.025. Do you see that anywhere? There it is. And it's 1.96.
Yep.
So they have their little table that they pre-computed for us because these calculations used to be, very difficult. And they've put in handy little numbers like a half, 4/10, 3/10, 2/10, 2.5%. With your calculator, it's just as easy to do 2.5% as it is to do anything, 3.7, pi percent, anything you want. Great. Part B.
Right. So we know that Z is 1 point. So if we restructure, should it be like capital Z is greater than 1.96? So wait, is all the information I need is that?
Let's see. So it's normally distributed. Mean is 80. Standard deviation's 4. what score will get you on the program? They have to be in the top 2.5% of candidates.
So is that like 90? So is that like me doing 0.975 times that answer?
7.5. No. So it's basically for this one up here in the standard normal. The Z. I'll do it like that. No. I'll just do one diagram. This is the top 2.5%. Also written as 0.025. So far, so good.
Yes, yeah.
The Z that gives you that for the standard normal is 1.96. You have to find the X that gives you that in this specific normal, where the mean is 80 and deviation is 4.
So the mean is the middle bit of like the graph.
Yeah. And so it's for the Z one for standard normal, it's 0. For this one, it's 80.
So I don't know if I need to do like 1.96. Oh wait, am I doing 1.96 times 1.025?
No, this is Z.
Yes, yeah.
Let's see. This is mu. This is D. We want X.
Oh, right.
That allows us to convert between them.
So we're going to do 1. Oh no, we're going to do 1.96 equals to X minus 80 over 4.
Yep. Come on.
And so should I give a exact number or insignificant figure?
3 sig fig.
So 87.8.
So X is 87.8. Does that look about right?
Yeah.
Yeah, it should be. It definitely shouldn't be less than 80. Okay, how about the one underneath?
So now we go back to inverse normal.
Yep.
And so that will be I got 1.64.
Okay, and B. What would it be? What would it be to 5 sig fig?
1.6449.
Okay.
And then now if I do, and so now I'm doing 1.6449 equals X minus 65 over 7.2.
Yep. So solve that.
And then That gives me 76.8.
Let me try to cheat. So this is greater than the top 5%, so 0.05. The tail is right, so it's greater than. Specifically, the mean is 65. Standard deviation is 7.2. Is that what you got? 114?
For which one, sorry?
For the one we just did?
I don't think I got 114, no.
What did you get?
I got, if I go back, 1.644.
No. What was the answer you got just a second ago for X?
Oh, it was 76.8.
So that's correct. Why am I not getting? Why is this not working for me? Who knows? You're using the right method. 77 to the nearest whole number. That was 87.8. Yes. So this thing that you just did there, you get the Z that you need, and you put in the mean and standard deviation and you solve for X. Well, you do the same thing for the ones we were doing at the beginning, except you put in Z and X and deviation and solve for mean. Or put in Z and X and mean and solve for deviation. Or put in 2 into 1, 2 into the other, and solve simultaneously. But we're all right. And so that stuff, what do you give yourself?
Probably a tick.
So that's all right. So actually, I said bad stuff about Bookie, but I mistook the questions. I thought they were something else, but actually the book has them in the right order. Okay, and so we still have more normal distribution to do for next time. Lots more. They now do a mix of binomial and normal, which is barrels of laughs. Yeah, how is that for you, Andrey?
Yeah, that was good, thank you.
And so mechanics next time?
Yes, please, yeah.
Okay, any questions for me in general?
I don't think so.
All right, well done, Andrey. You did great. I look forward to attending again next time.
Yeah, see you on Monday.
Oh yeah, have a good weekend. Take care.
You too, goodbye.
Bye.